Good morning, HVAC team. We're about to jump into chapter 21, which is refrigerant system testing and servicing equipment. Stuff that you guys are familiar with by now. We've been using a great deal of different tools and instruments, so this will just be review for some of this stuff. So the objectives are: list the different types of thermometers, explain the advantages and disadvantages of each type of thermometer, list common air temperature measurements technicians make, list the different types of gauges that can be used to measure pressure, explain how gauge accuracy is stated, explain the operation and use of a manifold gauge set, list the types of positive shutoff and low loss fittings available, explain why a micron vacuum gauge is used to measure vacuum instead of a compound gauge, and list the different types of refrigerant leak detectors. Excuse me. So thermometers, these are commonly used by refrigeration service people. Their reliability and relatively low price are reasons they are extensively used on large central heating and cooling plants. So they're showing some pretty old school looking thermometers. When they're talking about the larger plants, you will see like a lot of old school thermometers wall mounted, or some of them look like clocks, the big dial type mounted on the wall. And you know, in places like walk-in refrigerators, walk-in freezers, and places where they need to monitor their the temperature all the time. And more like residential air conditioning and things like that, you won't really find a lot of those types of thermometers, but you'll have your own digital pocket thermometer that you're gonna want to have with you on every service call. Also, you're gonna want an infrared thermometer. So digital thermometers, these are popular because of their speed and their speed in sensing a change in temperature and ease in reading the alphanumeric display. There are many features available on some models. So this is the same type of electric thermometer that I have on my gauges, and a lot of you will have the same kind when you get your digital gauge set. They're the clamp-on types, so you just clamp that onto your refrigerant lines that you're measuring, and you'll get a temperature reading. So on here they have a digital thermometer that is plugged to, but as some of you already know, the digital manifold gauge set has a temperature function, so you don't need a separate digital thermometer. These plug directly into the gauges, and you'll read various temperatures, so you can get your superheat, subcool, or whatever. Thermocouple temperature sensors and bimetallic devices. So thermocouples are made of dissimilar metals that are connected at the ends. Advantages and disadvantages and how to use them. So thermocouple temperature sensors can be used to detect temperatures that are displayed on analog or digital instruments. Type J, iron and Constantan, I probably butchered that word, and type K, chromal and aluminal sensors are two types. The K type, I believe, are the ones that we use the most, or the ones that I have. When taking the temperature of a refrigerant line, make sure the tip of the thermocouple is tightly pressed against the line. So when you're using your thermocouple to, I should have brought my tools in. When you're using a thermocouple, you want to tape that to the line. You want to make sure the tip of it is pressed up nice and solidly against that line, and you want to tape it up pretty good to hold it against the line, but also to insulate it so it's reading the temperature of the pipe and not the temperature of the air surrounding the pipe. Air temperature readings. So these are the old school analog type of pocket thermometers. Let me just make that a little bigger. I have a few of these that I've never once used in my life, but they got them, and look, it's UEI brand. I thought that was actually from our school, but it's not. There's a brand called UEI, but it doesn't have anything to do UEI, the school. But anyway, so these are pocket thermometers that you're going to do exactly what you're seeing them do from time to time, all the time. This one looks like it's inside of a supply grill. This one looks like it's directly in the plenum or in some square duct, and they're just taking temperature measurements to see how their system is performing. Again, I've never used my old school analog kind. I did get it in my toolkit when I graduated from trade school years ago. You guys are a little luckier. Your toolkits got the digital kind that I use, and your kits are actually pretty good. I don't even think I got a power drill in mine. You guys get an actual DeWalt drill. It's not an impact gun, but it's a drill, so it's good. At least it's part of the set. As you start to accumulate, that'll be one thing you already have. Yeah, so y'all toolkit kits are good to go. But anyway, so outdoor ambient temperature readings should be taken in areas that are free from discharge air from cooling units or dryer vents. Accurate return air temperatures can be obtained by holding a pocket or digital thermometer in front of the return grill. Supply air temperatures can be more difficult. The unit should be operating long enough for the supply air temperature to stabilize. The temperatures read at the registers, the temperatures read at the registers will be different from the temperature at the unit because of duct loss and gain. So what they mean by that is if you check your temperature right at the plenum, right as it's leaving the evap coil, it's going to be colder than when you check at the vent, which is at the end of the duct run, because typically it might be it'll be a little warmer, and not all the time. Well, yeah, it'll be at least a little bit warmer, and that's because as the air travels from the plenum all the way through the duct and then out of the supply vent, it's going to pick up some heat. The ductwork being in that hot attic, even though it has a thermal barrier on it, which is the insulation, it's still going to pick up some heat. That thermal barrier resists heat. It doesn't completely 100% eliminate any heat gain in that duct. So with that being the case, the air coming out is going to be a little warmer than the air going in. Pressure measurement, proper gauges versus dangers. Proper orientation of refrigeration equipment depends upon maintaining the correct pressures throughout the system. I think I said orientation. I meant to say proper operation. Anyway, technicians must be familiar with the range of pressures and types of equipment required. So these are some refrigeration gauges. Mechanical gauges require a physical device to translate pressure changes into movement that could be used to move a dial. A high pressure gauge has a single continuous scale. The low side gauge is a compound gauge that measures both pressure and vacuum. Gauges are classified by their percentage accuracy. Gauges are available in different sizes. During operation of an AC refrigeration system, the high side pressure may rapidly pulsate as the compressor valves open and close. The most advanced gauges use digital pressure transducers to read pressure instead of the Bourdon tube gauges. So let's go back to a couple of things that was mentioned. I'm going to make that a little bigger. So one of the things mentioned was the mechanical gauges have to convert mechanical movement into a pressure reading. So that's done. And so these are the kind of gauges you're going to get, by the way. This is going to be your high side gauge. This is your low side. They're both going to be attached to one manifold. A lot of you have already had plenty of experience with gauges. So anyway, so the kind that you get in your toolkit are the mechanical type, and it has this Bourdon tube on the inside. And so when the refrigerant pressure goes into the orifice and fills the Bourdon tube, it's going to expand. It's going to open up. And when it does that, it's going to turn these gears, and on the other side of that is a needle, which you can see in this illustration. And so as this opens up, it's going to turn that gear, and that needle is going to start to move. And then when the pressure is reduced, like when you take your gauge off, or if the system changes, like if the system turns off and the compressor is off and the pressure starts to balance out, this Bourdon tube will start to contract, and then it's going to move the needle back in the opposite direction, going back towards zero. So that's how the needle is moved, just basically by the pressure, which is illustrated by this blue color, this blue fill-in color here. Once that pressure is inside of there, it's going to open, or it's going to expand or contract. As it does so, it's going to move these gears one way or the other, moving that needle up or down the dial. So that's how the old school kind work. The digital ones use sensors and transducers and things that give you pressure readings and temperature readings and all this other stuff without having to use any mechanical motion to do so. So these are the kind you want to get when you get out there, because they just do so much more. It's like having a whole tool bag in one, rather than the old school mechanical gauges, because you're going to need additional tools and charts in order to do more stuff. So, and we can kind of get into some of that later in the chapters, but some of you already know what I'm getting at. But these are the kind that you're going to get, mechanical gauges. Down here, these are your digital gauges. This, I believe, is Yellow Jacket brand. I don't like them. They're ugly. My fill pieces are just nicer, and I like fill piece. I like that warranty. So anyway, another thing I wanted to mention is the high side gauge, as they said, is just a pressure gauge, but the low pressure gauge is a compound gauge. It reads both positive and negative pressure. So notice zero that's it, and that's all. The zero is as low as the high side gauge goes. But if you look at the low side gauge, which is a compound gauge, zero is here, but then you still have this green area below zero. That is a negative measurement. That's your vacuum that they're reading when you're doing an evacuation. Although that's not what you want to go by, because it doesn't go as low as you want. It only reads inches of mercury. And we want to get as low as, we want to get down into microns, which is why we don't measure our vacuums with our compound gauge. We get a separate micron gauge. Or if you got digital gauges, it's a micron gauge built in. So again, it's like a whole tool bag in one tool. So reading refrigerant saturation temperatures. Refrigeration gauges read system pressure and show refrigerant saturation temperature of common refrigerants. Digital gauges often have built-in saturation temperature tables for multiple refrigerants. Again, digital gauges are superior. So the gauges are reading, so every refrigerant pressure has a corresponding saturation temperature. So meaning, let's see if I can make this a little bigger. So what is our, okay, so let's take 410A, for example. 410A at 150 PSI gives us a saturation temperature of a little over 50 degrees. So if that's 60, then I'm gonna say this is 55, nope, 52, 4, 6, 8, 10, yeah, so 52. 410A refrigerant at 150 PSI gives us a saturation temperature of 52 degrees. That same refrigerant, if it were at 100 PSI, it would give us 30 degrees of saturation temperature. So that's what the gauges are showing you. The drawback for the mechanical gauges is that it only has, this particular one only has one scale for 410A refrigerant. So if you were to be on a system that was using R22 or 134A or something like that, then this scale would not tell you the correct saturation temperatures. At that point, you would have to pull out a pressure temperature chart and compare that pressure to the corresponding temperature for your given refrigerant on that chart. The again, digital gauges, all you have to do is just select what refrigerant you're working with, and it's going to convert the saturation temperatures to the correct table. So it doesn't matter what kind of system you're working on, you can get the correct saturation temperature. As long as you make sure you set the gauges to the, there's a refrigeration button. You just hit the button and switch it to whatever refrigerant you're working on, and these numbers will magically change to reflect the correct refrigerant table. So again, the digital gauges are just far superior. It's a time saver. Instead of having to pull out PT charts, just push a button. So gauge manifold set. So this is what they look like. This is the ones y'all gonna get. Keep them. It's always good to have as a backup. I hoard tools. I don't get rid of nothing. I got broken tools that I should get rid of that I just won't. You're always gonna need a backup. So get your digital ones, but keep your mechanical ones. So anyway, technicians use the gauge manifold to diagnose trouble in refrigeration systems. A more advanced gauge is the 4-port manifold. So that's the kind that I have. I got 4 ports. So the whole purpose of the 4th one is that it's a larger port. So you can hook up a larger hose for a faster vacuum, which is why it says VAC on that 4th port. That's your vacuum port. Not that you can't do a vacuum with the yellow hose, which is what you would do if you had a regular 3-port setup. But if you got the 4-port, might as well use the bigger one so you can try to get that evacuation done a little quicker, even though they're pretty unpredictable. So standard gauge manifolds have a bore of 1/4 inch and the same as the typical hoses on a standard gauge manifold set. Refrigeration hoses. Charging and vacuum hoses are available in different lengths and bore sizes. Refrigeration hoses are available in many colors, with blue typically low side, red is typically used on your high side, yellow is your utility hose or your service hose. That's the one that you hook up to your nitrogen tank or your vacuum pump or your recovery machine, your refrigerant cylinder, whatever you're doing, that's your service hose. And your blue and red hoses are always directly to your system, high side and low side. Although some people got gauges with just all black hoses, where they, that's that advanced stuff. I don't need no color code. I know what side is the high side and blah, blah, blah. I like the color code because, I don't know, I guess I'm just used to it. Refrigeration hoses are built in different layers. They have working pressures of 500 PSI and burst pressures of 2,500 PSI G. Positive shutoff fittings. Positive shutoff fittings allow technicians to control the flow of refrigerant leaving the hoses. Positive shutoff fittings are used to protect the technician from refrigerant spray and reduce refrigerant loss. There are different types of positive shutoff fittings, including check valves built into the end of a hose, which is a low loss fitting. Is when there's a check valve built inside of your hose, and when the pressure is released from that valve, it closes. And like every check valve, it allows flow in one direction and not the other. So once pressure is released off of that valve, it won't allow any refrigerant back out of that hose. So when you're taking your hoses off of a system, you don't have to worry about so much of that spray that comes out and freezes your fingertips and wastes your refrigerant. You still might get a quick little psst, but it's a lot less than a psst. And a lot of times people start panicking once that starts flowing out, and then they freeze up. And I always tell people, don't do that. If you freeze up, you're gonna stand there and wait until the entire system is flat, and you just release all the refrigerant out of it. So before you go hooking up to a system or detaching from a system, be sure of what you're doing, be ready for it, have your gloves on, and go for it. And there's a simple solution too. When you're unscrewing the hose and it's spraying you, and you're like, oh, my hand's freezing, you want to stop, you can just do this and continue to hurry up and unscrew it. And yeah, you'll feel some of that coolness, but most of it's going to just shoot straight out. So if you're doing all this, do that. And it'll keep spraying, but the quicker you undo it, the quicker it'll stop. Or make sure you got some good low loss fittings. Digital system analyzers. Some of you might recognize these right here. These are the gauges I've been talking about all day, my digital field piece gauges. So there are a number of combination temperature and pressure test instruments available for HVAC service work. Subcooling and superheat meters have a pressure port that is attached to the refrigerant's access valve and thermocouple that are attached to the high side. Some of these meters are classified as data loggers because they record the pressure and temperatures over a period of time. Some manifold gauges measure several readings, such as subcooling and superheat. So again, these digital gauges are just superior. I didn't have one of these. I did have at a different company when I first got into the trade. I was working at C&L. They supplied all the trucks with superheat and subcool readers, and it was a whole separate tool. I had my mechanical gauges hooked up. Then I got this whole other tool, which is basically like a dual input thermometer, and you just you have to tape the thermocouple to the suction line and tape another one to the liquid line, and then it calculates your superheat and subcool. These do that. So get you some digital gauges. You can read your superheat, subcool, your saturation temperatures for every single refrigerant, everything you need in one. Your micron gauge, all of it. So moving into micron gauges. Micron vacuum gauges are used to measure deep vacuums below the level that a compound gauge on a manifold gauge set can display. Most gauges can display vacuums down to 50 microns, which is crazy. 500 is the target. If you get below 500, you're just in good shape. I did an install this weekend, and it was, it's a brand new install, so the recovery is usually not recovery. The evacuations usually go pretty good on, on a brand new system. So, plus it doesn't even include the condenser because we don't even open the valves on the condenser until the evacuation is complete. So with that being the case, usually on a brand new install, the evacuation goes pretty quick. And in this case, it did. It was already at 500 before I was even ready to start it up. So I let it continue to evacuate while we did other little odds and ends. Once we were done, I got that thing to 300 microns. So I know some of y'all can appreciate that. It was a good day. So anyway, leak detectors, importance versus different methods. So some leak detectors work better in some locations than others. You should have more than one leak detection method available. So electronic leak detectors, those are pretty common. It's got this little sniffer on the end that picks up traces of refrigerant in the air. So electronic leak detectors are capable of detecting leaks as low as 0.4 ounces per year. If you are looking for a leak in an enclosed space, the leak detector may sense the refrigerant in the air. Which is why sometimes, most of the time, these are hard to pinpoint the leak. They can get you in a general area, but if they're, let's say it's in an enclosed area and it's been leaking for quite a while, as soon as you enter the room, that thing might start going off. So you're nowhere near, pinpointing that leak. But you can get in the general area because the intensity of the beeping, it'll increase the closer you get to the leak. Then you got to pull out your soap bubble and start spraying stuff because that's the soap bubble is the only way to pinpoint the leak. Ultrasonic leak detectors. An ultrasonic leak detector will detect any gas leaking through an orifice. They measure sound waves through different frequencies. So basically, it can hear the leak. Ultrasonic leak detectors hear the sound or that slight hissing of the pressure escaping the system. Electronic sight glass. The electronic sight glass has both visual and audible bubble detection. Now that's one that I've never used, and I think I'm gonna get, because it's a pretty cool tool. So it's got these two little sensors that you put on the liquid line in various areas, and it'll let you know if there's bubbles in your liquid line coming out of the condenser or before or after your filter dryer, to let you know different things. You know, you've got bubbles coming out of your condenser, that's letting you know that it's not 100% liquid coming out of there. Your subcool is probably going to be off. Or you can use it, it'll let you know if you need to change your filter dryer. Or also it can detect liquid droplets in the suction line, you know, letting you know if there's liquid going back to your compressor or different things. So that's actually a pretty valuable tool to have for troubleshooting, because it eliminates having to connect your gauges to a system like on a routine maintenance, because you don't want to just hook your gauges up willy-nilly just to any system. I mean, that should be the last thing you do when you're troubleshooting. First thing, obviously, talk to the customer, see what's going on, start doing your checks or whatever, but you hook up your gauges once you suspect that there's a charge issue, and now you have to hook up your gauges. But you don't want to hook them up all the time, because every time you do, you lose a little bit of refrigerant, and also you contaminate the system a little bit each time because of the oil in your hoses, oil, air, dirt in your hoses from other units, and so it's it always, there's no way around it. You always contaminate a system a little bit when you hook up your gauges to it. So it's a small change. It's not necessarily going to affect the unit, but it's just something to be cautious of. So anyway, electronic sight glasses help you to diagnose without hooking up any gauges. So that's a good one that I think I'm going to go ahead and invest in. Digital charging scales, something we use in class all the time. Digital charging scales are used to precisely weigh the amount of refrigerant added or removed from a refrigeration system. There are 3 general forms of these types of scales, including ones with removable displays. I like the removable display because it's basically like a remote. It's corded, but it's like a remote, so you don't have to really kind of hunch over and stare at the scale. You can hold it. But these scales are cool because they measure weight, positive and negative weight. So basically, if you're removing refrigerant from a system into a recovery tank, then that recovery tank is going to get heavier and heavier, and it's going to give you that reading. But it also reads negative measurements. So let's say you're charging refrigerant into a system. You put that cylinder on the scale, and let's say that cylinder weighs 10 pounds. As you start to charge, it's going to start losing weight, and the amount of weight that is lost is how much you put into the system. So that's how our digital charging scales work. So in summary, making accurate temperature and pressure measurements is essential to all refrigerant system service. Types of thermometers include glass stem, dial, digital, and infrared, which is the laser kind. The most common sensors used with digital thermometers are type K and type J thermocouples. 3 types of mechanical pressure gauges are diaphragm, bellows, and Bourdon tube. Digital gauges are more accurate than mechanical gauges. A gauge manifold set consists of a manifold with a compound and a pressure gauge, valve to control flow through the manifold, and connecting hoses. Gauge manifolds and hoses are often color-coded, blue for the low pressure side and red for the high pressure side. Common refrigerant leak detectors include soap bubbles, electronic leak detectors, ultrasonic leak detectors, and fluorescent dye. The fluorescent dye is not one I use very often. I think they're making them better now, but they used to clog up TXVs on certain units, so it was something I was always advised against, so I haven't really used it a lot. I've used it once, and it worked, but again, it was just something I've always been kind of leery about doing. But anyway, so that's it for chapter 21. Any more information on chapter 21 is in chapter 21, so read your books. The review questions are on FlexiQuiz. Study up, stay motivated, stay safe, stay in the house, stay healthy. We'll be back soon, hopefully. Till then, I'm going to be doing these videos, so I'll see y'all on the next one.